Let's take a look at how we find the domain and range from a graph. To find the domain, find the points farthest to the left and the right. Your domain is your x values, and your x values determine how far away from the y-axis you plot a point, how far to the left or how far to the right you go. So if we look at, let's try a different color. If we look at this first graph, the point farthest to the left is right here, and farthest to the right is right here. Now look at the x values at those points. This is the point -3, -2. This is the point 3, 2. So the domain goes from here over to here. All of these x values have points somewhere on the graph. Nothing on the outside of these does. So the domain here is from -3 to +3. And since these points are colored in, they are actually part of the graph. So we use a bracket to indicate that, -3 to +3. The domain in this case, because this goes forever that direction and forever that direction, and even though those kind of look like they're pointing up and down, they're also pointing to the left and the right, indicating there's no stopping point. So the domain here is from -infinity to +infinity. And likewise, this, again, they're pointing up, but they also mean it never stops. So it goes out forever and ever. So the domain to this one is also -infinity to +infinity. What about the range? To find the range, you want to find the highest and lowest points. Anywhere on the graph. Now, your domain tends to be at the ends of the graph, but your range is less likely to do that. The lowest point on this graph is right here, and the highest point on this graph is right here. Looks like 2, 1, 2, 3, 4. So here's the point 2, 4. Here's the point -2, 1, 2, 3, -3. So the point that has the smallest y value is right here, the lowest point. The point that has the highest y value is right here. So the range on this graph goes from here to here, so from -3 up to 4. And those points are part of the graph, so we include them. What about this one? Again, that's up and down forever, so it goes forever up, forever down. The range here is also -infinity to +infinity. Now, this graph obviously has no highest point, but it does have a low point. It comes down to here and turns around and goes back up. Looks like 1, 2, 1, 2, 3. This is the point +2, -3. So the low point here is at the -3. So here's the range. So the range here goes from inclusive of -3 up to infinity, and of course, infinity always gets a parenthesis. Let's take a look at increase, decrease, and constant intervals of a graph. This is actually asking us what the y value is doing as the x values go from left to right. If the graph reading from left to right is going up, it's increasing. If the graph is going down, left to right, it's decreasing. And if it's just running horizontally, it's constant. Whatever our x values are here, as our x's get bigger, our y's get bigger. As we look at these points, as our x's get bigger, the y's get smaller. And here, as the x's get bigger, the y's don't change at all. Now, the catch on this is that they don't actually care what the y's are increasing to or what the y values are. They are only interested in whether they are getting bigger or smaller and over what period of x values this is occurring. This is always in terms of what the y is doing but what the x values are. They want the answer, the intervals in terms of the x values. So here we would say that the x values are, the y values are increasing as x goes from negative infinity to positive infinity, assuming there's an arrow over here. And here the y values are decreasing as x increases from negative infinity to positive infinity. And here they're just the same as x goes from negative infinity to positive infinity. Let's take a look at a graph. This is a word problem from the PowerPoint in this section. This graph shows the relationship between the number of gallons, G of T, gallons in terms of T, of water in a small swimming pool and the time in hours T. So G of T, the Y value is the number of gallons in the pool at any time T. Here's our time, here's our gallons. So the time is the X value. In this case, we're using T. The Y is the time, is the number of gallons. By looking at the graph of this function, we can answer questions about the water level in the pool at various times. For example, at time 0, the pool is empty. When T is 0, the Y is 0. The water level then increases, stays constant for a while, then decreases, and then becomes constant again. So the domain here, what are the X values? The domain, the farthest left point is 0. The point farthest to the right is 100. Both points are included. So the domain here goes from 0 to 100. The range goes from the lowest point is here. The highest point, these are all tied for highest. That's 3,000. So the range goes from 0 to 3,000. Now, it does increase from 0 gallons to 3,000 gallons, but they don't care. When they're asking about the interval where it's increasing, they want to know over what interval of X values did the Y values increase. And the X values from 0 to 25. For increase, decrease, and constant, the definition of a point being a point where the Y values are increasing is that the Y values to the left are smaller and the Y values immediately to the right are larger. So at this point, it doesn't meet the definition of being a point where it's increasing, because it's increasing as it approaches this point and then it flattens out. So we always put increase, decrease, and constant as open intervals. In other words, we use parentheses no matter what. So they want it in terms of the X values. As the X values go from 0 to 25, the Y values were increasing. So we put 0 to 25 for the interval of increase. From 25 hours to 50 hours, the Y values were constant. So the interval where it's constant is from 25 to 50. Again, all parentheses. From 50 to 75, it's decreasing. So 50 to 75 is an interval of decrease. As the X increased from 50 to 75, the Y values decreased. They're not interested in the fact that they went from 3,000 to 2,000. They are only interested specifically, as far as numbers, in the X values. And then from 75 to 100 hours, it was constant again. So this is going to be union 75 to 100. It doesn't have to be either increasing or decreasing, but it does have to be increasing, decreasing, or constant. So between all of these, it should cover the entire domain. So we've got 0 to 25, 25 to 50, 50 to 75, and then 75 to 100. And that's how you find the increase, decrease, and constant. So the main thing here is to remember to put your intervals of being increasing, decreasing, or constant in terms of the X values where that occurs. And to keep it as open intervals, in other words, just always use parentheses on that. And that part you're just going to have to memorize.